Okay, I think it's live now. So go ahead. But before you do that, don't just don't start. We need to get people first to join the call. Shall you get? Um,
Okay. Do you have anybody? I can't even wait. Oh, I'm not logged in.
Cause sometimes I look in her eyes, and that's where I find a glimpse of us. And I try to. Rien de rien. Non, je ne regrette rien.
What's your favorite food as a traditionalist rapper?
Bad times where I pay bright price.
Good evening, everyone. I see some people have joined. So let's just like wait a few minutes and then we begin. All right. Let's begin. I welcome you guys once again to the AWS Cloud Club workshop. So I said earlier, today's workshop is going to be a bit different from the ones that we've been having in the past. In the sense that today we're going scenario based. So we take a scenario and then we build a solution around that scenario. All right, so let's get into it. So today's scenario, I'm not even showing this. Yeah. Yeah. Yeah, this is the scenario that we're going with today. So just to confirm, like I hope everyone can see the screen perfectly. Let me check it. Yeah. So a small e-commerce startup owns a weekly snapshot of their business performance delivered to the team every Saturday afternoon. So managers want it in their inbox, then the founder wants an SMS, and then the developers want it in Slack. But nobody wants to manually like pull the reports. Like nobody wants to call an API to get the report. They want it automatically every Saturday or like weekend. So now this is a problem, right? This is a problem that could be solved in like a lot of ways actually. So one way you could solve this problem is together with the e-commerce application, we can like embed the code for doing all this. So the code for sending messages to sending email alerts, for example, sending SMS and all that, even like Slack integrations as well. You could embed this into your code directly. But when you go that route, there's always like trade-offs. So when you go that route, you get like for example now the server you are already provisioning, everything stays on your server, right? You don't pay for extra, everything still stays on your server. But what of a scenario when the data you're trying to perform the analysis on is very large, right? So, say for example, Amazon, right? They process probably like a million transactions in a day. And what if every week they want to get a summary of that kind of transaction and maybe like pass that to an AI model or like just want a summary of their transactions every weekend? If they were to embed that into their application, imagine like 1 million transactions every day over the space of a week. That would be like tens of millions of transactions. Now, when you're trying to like crunch the API, when you're trying to like write an API to do that, there are several things. Your code first has to be clean. Your server has to be like strong enough to even like take those longer running like database queries. Slack integration again might be another thing that you might not have directly into your code, that you might have to like install a third package to do that. So embedding all this inside your code is possible, right? But it's not optimal. In the long run, it will stress your server, right? And imagine if at the same time when you're trying to get the summary, you're also having customers coming to your website as well. So like that's just increased load that you might not even be prepared to handle. So this is where serverless comes in. Serverless in the sense that those parts of your code that that part of your application that don't need to be run every single time, you can make them serverless. And when you make them serverless, it still runs on a server, right? But you don't really care about where it's running. All you care is that okay, when you need this to run, it's going to run. So the whole part of getting the summaries and everything, you could create a serverless task for that to handle that, especially, and then every Saturday it's going to run, and then once it runs, it does what it's supposed to do, and then it terminates till the next Saturday again. So now imagine, so if you are doing that every Saturday, you're only going to be paying for, let's say the job runs like 10 minutes every Saturday. So in the long run, you're only going to be paying for 520 minutes in a year. That's a small amount of money compared to what you'll be paying for in your original server, right? So yeah, that's just an explanation of the solution we're going for. Now the solution here, let's dive into the solution. So since we're using AWS now, AWS already offers like a whole range of serverless tools that we can make use of. And one of them, the most important one here is SNS. So let me just put that down here. So SNS stands for Simple Notification Service. So it is like the acronym SNS, like probably just explains what it does. It's a notification service. It comes in this solution in a way that okay, since you already identify the problem here, the problem is that you want a weekly snapshot, right? So what if you could just like write a piece of code that will calculate this weekly snapshot, and then whenever you have your Saturday or whenever anytime you want to do that, maybe it's at the end of the month, if it might not be every Saturday, the code is going to run, and then this SNS is going to like spread out and notify everybody that is concerned. In this case, it's the manager, the founder, and the developers. So give me 1 second, please. Okay, yeah. So yeah, simple notification service is Amazon's AWS's like very powerful tool for spreading out notification to everybody involved. Now, this is just the notification itself. So the actual compute, so what's actually going to run and calculate the summary, what's actually going to run and call the API for handling that, what's actually going to like run the actual code itself for doing this. So now here we have another option. So the first option that we have is Lambda. So it might all be familiar with Lambda. So Lambda is for running serverless functions in any programming language of your choice. When I say any, I mean like the popular one, sure, but like it supports a lot of programming language, so we can also leave it as that. So yeah, Lambda is for running serverless functions. It's a very powerful tool. It comes with its constraints and it comes with its benefit as well. We'll talk more about that. And then there's also ECS, which is Elastic Container Service. Yeah. So what's Elastic Container Service? Elastic Container Service is another powerful It can be serverless, it can be server, and it can also run on EC2 server based on your choice. It's a service for running containers, like basically just for like running your Docker containers. Like that's what it does. Now for this use case, we are going to be using ECS. And why are we going to be using ECS? Why don't we use Lambda? Right. So this is a kind of question that you might want to ask. Why are we going to use ECS and not Lambda? So Lambda, like I said, it has some should I say like downsides. And the most powerful downside here is that Lambda cannot run more than 15 minutes. Right. So it has a constraint of 15 minutes. That's one. The second one is memory requirement. So I think when once a Lambda function is running, there's a memory cap on it. I don't know. I think it's around 200 MB or something like that. So once like the process of running that function has taken this amount of memory, it's going to terminate whether it's done or not. So imagine, like I said now, for Amazon being the use case, if they are trying to run a serverless function now to that's probably going to call an API that's going to call like 1 million records on a database, or like probably going to do some complex calculations, or like maybe a long running, some tasks are long running in general. So these are like batch jobs. They are long running in general. If you try to run that in Lambda, it's going to time out. And once you time out, whether it's complete or not, it's going to like cut you off, right? Now, we're going to be using ECS in this case because ECS is going to solve that problem. Since we can just run our containers, there's no restraint. For how long this container is run is where you're going to be built. They don't tell you that, oh, your container will run for this amount of time and this amount of memory requirement. It's as much as you want it to run. So that's how we're going to be using it in this case. Then what we're actually going to be using again for the scheduling. So this part here, I said every afternoon. By default, Lambda will run on trigger. Like something will have to trigger it. Same with ECS. Like you need to trigger it. You can run it by yourself, just run it forever. But in this case, we need a trigger. And the trigger in this case is known as what? Event bridge. So event bridge is if you are familiar with uh cron jobs, something so it allows you to run cron jobs. So cron jobs are just like tasks that run when you want them to run. So if you want your system to update every single day by 2 a.m., for example, now you could write a cron job that's going to do sudo apt updates for you every 2 a.m. So it's built into most operating systems and even like most programming frameworks. And there's also like a serverless version of it, which is Event Bridge. It's also a very cheap, well, not cheap, sha, but like very affordable service. So how does this all tie down? So these are the four key services, and how do they all tie down? Right. So let's just do a little diagramming here just to show you how it might all work. So you probably have like the API here. So am I drawing? You know, we can have like an API here, maybe like the e-commerce API or something like the e-commerce API. Can I move this? Yeah. Yeah, so we probably have like the e-commerce API here. So this is probably like the endpoint the company has already exposed on their on their application. They're okay. The serverless application can come query this to get the data, or even if they are running it in-house, maybe they aren't using serverless, they will surely have an endpoint, right? So the endpoint is where they will call and then they will get like whatever data they are looking for. So they have this. So now how are we trying to fit all this into this system here? We know SNS is for sending out notification. We know Lambda and ECS, they are for running the actual job itself, and Event Bridge is for scheduling said jobs. So how did they all tie down? So we're going to have our SNS somewhere like this, right? And I think I didn't even explain how they work. So we have our SNS, something like this. So I didn't explain this before. So how SNS works is that if you are familiar with the producer consumer mechanism, so that's how it works. So you create a topic and somebody subscribes to that topic. Any message that enters that topic will be automatically found out to the the subscriber. So we could have like many subscribers here. So probably can have like, yeah, could have like 3 different subscribers. How do I even select this? Yeah. So we could have like 3 different subscribers here. Not that one. Here. Yeah. So this could be SMS. This could be like say email, and this could be like Slack. Yeah. So you create an SNS topic, right? So the SMS topic is going to be the producer in this case. Then your SMS, your email, your Slack, maybe your Jira or something, all those things they will subscribe to. Once they subscribe to that topic, then automatically any message that enters the topic will be found out to these guys. So they don't have to manually be telling this guy, oh, do you have message for me? No, it doesn't work that way. Like they get it automatically. So it reduces that overhead of having to pull the the topic. And then we now have our ECS. So our ECS is the main thing that's going to run. So we can just have our container here. We can demo that with circle. Yeah. This is a container. So remember I said it could run in any application. It can be Flask, it can be Node.js. Okay, but let's just use Fast API for now because it's faster to work with and it's easier. So yeah, so this is what is going to call this API here. This guy is going to call the API, get the summary. Once he gets the summary, it then pushes it to the topic. Then once it's inside the topic then pushes it to these guys, right? So that's the whole mechanism. So it now eliminates the overhead of like stressing your server, for example, now to do all this kind of thing that might lead to more cost, it might lead to crashes, it might lead to like your server being deadlocked. It just like eliminates like all those problems altogether. So this is like the simple logical like diagram of how the system is going to work. You have your fast API application, which is going to be running in doc in ECS. So I should probably just write that here. ECS. So yeah, your fast API application running in ECS, and then it does what it pulls the e-commerce API, then it pushes it to a topic. And once it's in this topic, a topic can then push it to its subscribers. So like that's how the system's going to work for now. So now that we've outlined the architecture of what we are trying to create, so we can just go ahead and create this entire system here. So let me take you to my console, and then from there we can start creating. Okay. All right. So the first thing we're going to create now is our SNS topic, because our SNS topic is from our diagram. Technical glitch. Oh, nice. Okay. Yeah. Perfect. Yeah. So from our diagram, the SNS topic is actually what pushes all these things to our like channels. And then so we can just go ahead and create that first. All right. So before we even proceed, I just like to know if there are like any questions in the chat. So let me address them. So if you have any questions, you could just like drop them here, like in the if you're joining from YouTube, you can just drop the questions there, and I'll address them as we proceed. But I feel like we've discussed a lot already, and yeah, I just want us all to be on the same page. All right. So no questions, then we proceed. So we're gonna create our topic, and we can just call this like a weekly summary topic. You can create as many as you want. Yeah, so we're creating a standard. So there are two types of topics I can create: the standard and the FIFO. Then you can just go ahead and create them. Yep. So now that we have done this, we can also subscribe to this topic. Since for this, we're going to be using my email. We're going to be using the email address or SMS for this particular one. Yeah. So yeah. So let's just subscribe to it. And here we select the protocol. The protocol, this is where you choose. As you can see, there's SMS, there's HTTP. So you could even like trigger a HTTP pushing once data arrives. Well, we did just email for now. So we do that. And then we say put my email address. You can create subscription. So once you subscribe to once you subscribe to a topic, by default it's not going to be confirmed, but once you're going to get an email, and then once you get that email, you can see the status is pending confirmation here. So I have to accept that on my email address, so I'll just do that behind the screen. Okay, so okay, see, I think I'm subscribed to another one. You know what, let me try my other email address. I think this one's sending me to spam. Okay, yeah, so I think this one worked. Yeah, so yeah, it's confirmed. I think my other email address was sending it to spam, so I could not even get the email for some reason. So it might happen like that. Sometimes you create a subscription and then you won't see it, so you have to check your spam. And then, so once I've done that, I think I should just redo this other one. This one here. Let's request again. Okay. So we're going to use the first email then. So let's head back to our diagram. So yeah, we've created the topic, right? And we've subscribed via email. We've subscribed via the email. So what's next is the whole ECS part, right? Because the ECS part is there's a lot under the hood there. So you have your application, you have your container, and then you have like querying this particular API as well. So for all that, so it's a fast API application that I've already written, and I've pushed it to Git already. So if you go through this code, I'll leave it after the. I'll drop a link to this so you can look at it yourself. So this is just a simple fast API application, right? That's querying an endpoint. That's this JSON endpoint. Then it's just fetching the data and like just like simulating how it would happen in a normal e-commerce application, and then it prints out the message, right? And then this is the job itself. Yeah, sending every single thing. Why is my scrolling not working? Yeah, okay. I'm sorry. Then once it creates the summary here, it then pushes it to SNS. And then after it pushes it to SNS, like we're going to like get those get notification as well. So it uses the Boto this library here. This is AWS's SDK in Python. So in JavaScript, it's called AWS SDK literally, and in Python it's called Boto 3. So Boto 3 has basically all AWS services. They have like methods in them for interacting with those services via code. In this case, now you have to create an SNS client. So that's here. So yeah, you have to create an SNS client here. So you can see both the tree.client, SNS, specify the region, and then you just push. They're very simple to interact with. The documentation is that once you just search both the tree documentation, you see all. So like that's just all there is to this code. It's very simple. Then this is just the requirements. So using fast API, UVCon, HTTPX for making the API calls, and then Boto 3. That's the main AWS library. Then we have our Docker file because this is going to be running in a container, and it's just a simple Docker file for creating the raw image. So now for us to actually run this in ECS, so there are actually 3 steps in doing that. So I think I'll need to illustrate again for this. So essentially, when you like run a container, so first of all, you need a container registry. So a container registry is what? A container registry is just like it's like GitHub but for containers. GitHub stores code, right? You now need a place to store the actual image itself. So that's the container registry. In this case, it's called ECR in AWS, right? So this is where our containers are going to be lived, are going to be stored rather. Sorry, images, not containers. They are going to be stored in a container registry. Then we now need a way to push the containers, or I keep saying containers for some reason. So it puts the image to the registry. So we need a way to create our container registry first, push it to the registry. Then from the registry, we can then run a container from that particular registry. So as far as container registries are concerned, there are like several options. So there's Quay. So yeah, there's Quay. I think it's yeah, Red Hat Quay. I just want to show you some, like, in case you don't want to use ECR for some reason, you can use other one. So there's Quay, there's Docker. Docker itself has one. So if you go to Docker Hub, it's also a container registry. So and then there's ECR. ECR is Amazon's own. Yeah. So since we have our application, we should just go ahead and create the image. For creating the image, we just like do Docker build on this, and then we already have it. There are 2 ways to doing that. You could do it locally, right? You could have you can I can run this, I can like build the image on my computer, and then from my computer push it to the container registry. But I don't like doing that for some reason, because sometimes when you create an image, it can be very large. So it can be like sometimes 1 gig, sometimes 700 like megabytes, and because of my network, sometimes it will take, like, imagine uploading something of 1 gig to a registry. It takes time sometimes. So to combat that, you can use a server, an EC2 instance, because they usually have faster network, and you can just like create the instance, and then from there you build the image and push it automatically. It's all within AWS, and it's very fast. So let's just create the repository and I'll show you what I'm talking about. So can I just call it a quick summary, and we just leave the rest at default. Yeah, so we have this. And if you come here, you see they're already giving you like push command. They're telling you how to push to this particular thing. So you don't have to memorize anything. Thankfully, you don't have to memorize anything. Most of they've already put the steps here for you to doing that. But before we do this, I told you we're going to use a server to push to it. So an EC2 server. And the reason why I say why it's need server is because like the faster network speed on all these servers. It might be slower to push on my laptop. So we just launch an instance right now. And then we can call this ECR push server. So it's a good practice to create servers with a like good, like very descriptive tags, so that you know, because sometimes you can have plenty, and when you're searching for a particular server to connect to, it might be difficult to just locate them. So we just use by using Amazon Linux. So this is just the image, the AMI. So AMI is operating system that you're creating the server with. I think that's all we need. So oh yeah, a key pair. So you can just create one. So ECR server. So the key pair is actually beyond our so this entire process is beyond what we are going for, but to just explain it, this key pair is what will allow you to connect to this particular server. If you don't have the key pair and you create a server, you can't like SSH into it except you do that through this console itself. So let's just go ahead and create it. And yeah, I think that's all. You can just go ahead and launch this instance. And so if you come back here, we should see the instance, and we can be able to connect to it from here. Yeah, so it's running already. So we can actually connect to the instance. So there are two ways you can connect to it from here, meaning in the browser, you can do everything you want to do, or you can like use your normal terminal, for example. Your normal terminal, you can use it to connect. So I think for now we can just handle everything in the browser. Let's just connect here. So that means we don't even need the key pair we created. We don't even really need it again. So let's just connect. Um, So the purpose we are creating this server is to push our image to the registry, like in a faster way, a faster and more efficient way. Yeah, so we are in the server now, and whenever you create a server, the first thing you have to do is to update it. So let's just update the server. It won't take that much time. Okay, so it's already up to date. Then we install Docker. Why are we installing Docker? Because we have to build the image itself, and Docker is what we're using for now. So let's just install Docker. So it shouldn't take much time because we're working on the server. Like they usually have faster network speed, so there's no MTN wahala. Okay, yeah. So we have it, and then what we can do is we can check the version. I know it's already installed, so I don't even need to do this. Let's just start the Docker service. So you don't have to worry too much about all these Linux commands. Like you can just check the internet, and I think you just find them right there. So if you don't start, because this is a Linux system, I don't know about maybe like a Mac OS. Maybe if you install Docker, it starts automatically. I don't know about that. But like on a Linux, whenever you install a service, you have to start it by yourself. And one thing that you should always do again is to enable it. So if, for example, this system, the server should shut down and then it should come back up, Docker will still be running. So you have to enable it. So that's what that's about. And if I try to check where Docker is installed, I do my Docker version. So I'm getting permission denied. So that whole permission denied comes from the fact that like Docker does not, like this our user does not really have that permission to run Docker without sudo, and you can fix that by just adding it to the appropriate group. Like this is very small. This is better. Yeah. So now all we have to do is just disconnect. Oh, sorry. So we leave the server and then we'll come back to it again. So let's come back to it. So because of that command I ran, it requires you to restart your terminal. And there's really no way to restart like a terminal from the browser. So that's why I just have to disconnect and then log back in. So now once we are in, we can head into the important thing that we're trying to do. That's push the image. So sorry here. I could just copy something. Okay, it's back. Yeah. Let's copy it. Okay, yeah. So let's put our code here. So, oh, Git is never installed. Oh wow. Let's just install Git as well. My idea Git will be installed. Okay, yeah. So we can do that again. This is a public repo. Is it not? Okay, so we have the code here now. So that's it. So yeah. So the code has been checked out. You can see the Docker file, the main.py, and then the requirement.txt. So it has the same thing that we are having here. So we can then try to push our code here. So where is the, let's see. Okay, yeah. So blah blah blah, get this, get this. So I'll just show you an error that will occur. Like we could solve. I'll show you an error that will occur when you try to run this directly. Even if you run this on your laptop, you get the same error. So yeah, so you see, unable to locate credentials, you can configure the credential by running AWS login. Yeah. So if you are trying to interact with any AWS service, you have to be authenticated. So me creating all these things here, like me coming here to do all these type of things, I'm already authenticated. That's why I can do all this. So, but coming on the terminal now, or from another server, I'm not authenticated. So for you to do that, you have to create something you call access keys. And once you create that, you're free to then interact like as you please. So I think we need to. I already have my access keys here. Yeah. So they are temporary. I think they'll be deleted very soon. But um, so I think, okay. So let's just configure. So we do our AWS configure. So this is to authenticate with AWS from your terminal. You have to paste in your access key. I don't know why the stuff is showing, but if you try to use mine, it's going to be deleted. Anyways. And then your secret key. This is so trying to solution. Then your region. So the region we're working in is yes east -1. And our output. So this can be JSON, this can be YAML. Doesn't. So once we have authenticated, we can check whether you have authenticated by running AWS STS get caller identity. So this is to check the particular user that is going to be like accessing this endpoint. So if it's successful, you're supposed to get the results. Yeah. So you can see like our authenticated successfully. Then we can just go ahead and clear this terminal for more space. So now we can start running these commands one by one to push the image, to build the image and push it here. Then we take this right here. It's just building out the image. The first command we ran was to authenticate with ECR itself. Then this is the second one we're running. That's building the image. I think it has built. So let's just check whether it has built finish. Okay, yeah. So the image has been created. So it's 200 MB. It's not even that much. Okay. But sometimes the images are usually very large, so that's why I just have that habit of using a server. And then we're tagging it. So if you don't tag your image with the same name as the registry, you can't push it. So that's just something that when you work with Docker, you get used to that. If you don't tag the image properly, you won't be able to push it. That's how you have to tag it. And then the final command just to push. You can see all these stuffs are very fast. Like, so I don't know. It's just a hack, sure. Like you could do all this on your laptop, really, but I don't know. It's just faster to do it here. So once I come back here and I refresh, yeah. So this is the image that we just created, right? So this is our image, 94 MB. It's not large, right? So we've already pushed our image. Then what's next? So we now have to create a cluster. So we can You can navigate there from ECS from here. So this is the dashboard of ECS. And yeah, so we're going to create a cluster. So a cluster is essentially a cluster is a grouping of containers that are running, because when you are running containers, you can specify how many you want to. You can run like 5 containers, 6. They are all doing the same thing. But because you need that high availability, or you need the job done faster, or you want to reduce load on each particular container, for example, that's why we use a cluster. So it's just like a grouping of tasks and like other services running on that. So let's call it weekly summary cluster. So Fargate. So Fargate is a serverless. It's like EC2, right? But it's serverless. So just think of it as like EC2 but serverless. It can be more expensive. It is usually cheaper, but it's just like a serverless way to run applications. So it's a simpler way of putting it. Okay, so it has been created. Then once you are done with that, the next thing that you have to do is create a task definition. So now, what's a task definition? So when you come here and you click on this, so a task definition is actually, like a cluster is just a grouping of different tasks and services. So task definition is like, okay, these services that we're grouping together, or these tasks that we're grouping together, what actually constitutes them? That's the task definition. This is the blueprint for what each service is going to be, a blueprint for what each task is going to look like. And it gives us opportunity to specify different things there as well. So let's just create a family name. Say weekly summary task. So we're going to be using Fargate. So you could use EC2 instances. You could use like EC2 instances, and you could use managed instances, your choice. So your CPU, that is a small one. Memory, I think we can just leave. We'll delete all this afterwards, but you can choose like depending on, for this use case, if you want one gig was going to be sufficient. But let's just leave it as that. Then for the role, so whenever you are interacting with AWS and you are always seeing all this role. So the reason why a role is required, because all these services, for example, now, in order for them to be run, something needs to like stand in position in order to run them. It's just like, how do I put this? In order for you to like enter a house now, there has to be a gate man that will let you in. They will not be like, okay, yes, this person is verified. So like it's a way for extra security. So I think we've done like a session on security and IAM before, or I can just run you through it. So we have like IAM user, IAM policy, and IAM role, right? So role is just for short-lived. If you need an application to access another service for a short period of time, you have to give it a role. It's just like, oh, you want to enter this place, or you take this badge. Once you have this badge, you can enter this place. When you're coming out, you return the badge back to me. So that kind of thing. So that's why a role is. So you have to create a role. So let's give us a descriptive name, because the default name is, I don't like it. So weekly summary task role. Then so for the role, the this is S3. We don't actually need S3, right? So what we need is SNS actually. So we can edit this in line and say SNS. But first, let's add an existing policy, and that's ECR. Sorry. Oh, so I think it already has that by default. Yeah. So we need SNS, because our code is going to be calling. If you check our code, it actually references SNS. So if you don't give it that permission to call SNS, your application is going to fail. So we can just give it SNS full access for now, and just go ahead. So even if the roles we are giving it is not enough, we can edit it later on. After we've created, we can always edit all these things. So if it's not enough, it's going to throw an error, and then once we have the error, we can edit it. So now this container part, this is where you now specify your application itself. So this is the name of the container. It's going to be weekly summary, and then the image URI. So the image URI is the particular image that we pushed. Every image that you push is going to get this URI here. So you need to actually grab that. So you can just copy from here. Oh, they added this feature. Oh wow, this wasn't there before. Okay. And then the port that it actually runs on. So our application, I've forgotten where it even runs on again. Let me just check the Docker file. Okay, it runs on 8,000. So we have to open port 8,000. If you don't open it, there'll be no way for it to run properly. Then yeah, so our environment variables as well. So if you check here, our environment variables are not that one. Yeah, so we have this SNS topic ARN. That's the actual SNS topic that we're creating. We need the ARN, so we can just add that here. Sorry. And then the value will come to SNS, we come to our topic. Um, this is the topic, we copy the ARN. So ARN is just the special ID that is attached to every AWS resource. And the second one is what? So the second one is our AWS region. So our AWS region, we know is US East one that we are using. So we can go ahead and add that one. So our AWS region and CS East one. So if you are using a different region, you have to specify that one US East one, and that's what I specified in the application. And then so the rest of all this stuff is just for CloudWatch, it's just for log. So if something goes wrong, you can go and check. And this is where you specify storage. Because if you work with containers, containers are like they are stateless and they are short-lived. So if you run a container and it stops, everything like everything that's stored in memory, once it stops, like it loses everything. So if you want to add more storage, you can add that here, and it works with EFS. So this whole point here works with EFS. Maybe we can get into that later. So you can just create that. Let's just focus on the main thing that we're going for today. Okay, it has been created. Right. So once you've created your task definition, you can then go ahead and create your task or service. That usually is the same thing, but they can differ at times. So you come here. So let's create our task. So we select the task definition. I told you the task definition is like a blueprint. It's what is telling the particular task what you want to do. Then how many do you want? So we're just going to use one here because this is a very simple thing. And I think the rest will just be default. If you are going to specify networking, you do that here. By default, it's going to choose every security group in your VPC. Then your volumes, and we can just leave the rest of it. We don't really need that. So why am I running the task, man? I'm actually running the task bar right now to check like if everything's properly configured. Because once you use event bridge, you won't be able to trigger it by yourself. Once you use this part, oh, I didn't even okay. So I didn't add event bridge to this particular diagram. But no matter. So we're running this now to see if there's any error. So if you run successfully, I should be getting an email right now. Let us give you some time to create the necessary things. Okay. Yeah, so it fails. So let's just check. So I'm certain it's going to be permission error. Okay, okay. So unable to pull secrets from registry, blah 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 blah. It's not authorized to perform. Okay. So you can just inspect this with Amazon Q here. So Amazon Q is AWS's AI assistant. So you can just tell us, okay, what's wrong here. So I know the the error is coming from we didn't add an ECR role to the particular task definition. When we were creating that role, we added only SNS, but we didn't add ECR. So I'm sure that's what's going to tell us here. So because I know the issue, I can just go and address that by myself. But I would like to see what this guy tells me. Sorry. It's like this is taking like too long. Let me just wait like a minute. If it doesn't give me a response in a minute, I'll just fix it myself because I know where the error is coming from. Okay, yeah. So it has done its analysis. Look at what it's saying. It said the ECS task failed due to a resource initialization error caused by insufficient IAM permissions. So the primary issue is that the role we created it lacks the ECR permission required to pull the container, and then it can tell you how to fix it. Right. So go there, find the role, and attach the AWS management policy. Okay. So let's just do that. ECS task subscription management policy. So let's go back to our task definition. I think we can just close this up. We don't need the AI anymore. So if you come back here, so we can check the role. This is the role we created. So we have to add that permission. So we add the permission. Okay. Now that we've done that, we can try running it again, creating a different task. We can delete this one. This is on a new one. So we go through the same process again. Weekly task definition one. Yeah. So I believe it should work properly this time. So I know I'll be talking about a lot of things, but if there are any questions, please just don't hesitate to drop them in the chat. I'm actually checking it. And okay, so this person asking for the repo URL and the public one to fork. I'm going to drop every single thing at the end of this session. I'll drop every single, even both the steps to recreate this by yourself. Yeah. Okay. So I think it has already run because I just received an email. Yeah. So it is running, and if we check the logs, so to check that it ran successfully. So if it's running application complete blah blah blah. So yeah, it ran and I got an email. I don't know if this email I put here is locked in this particular. I'll have to show you. Okay, it's not here. It's not here. Let me check if it's here. Okay. Yeah. So basically, I've gotten an email. I need to find a way to display that too. So it runs successfully. Let me see if I can resubscribe with this particular email address. Oh, I can't even delete it. Oh wow. Let me try this again. Let me request confirmation. This Oh wow. Okay. So it runs successfully. Let's just focus on that. So now coming back to this particular diagram. So I left out something like very very important, and that's the cron. So should I just do that with a star instead? So yeah. So this is actually what schedules this. So it comes on this, and then this, yeah. So this is it. So our cron job here. So I can just tag this as event bridge schedule. So yeah, so the schedule is what actually like triggers this guy, and then from this guy it can from the ECS it can then like call the API. All right, so now that we're certain that the application runs perfectly, we can just go to event bridge and do a little test run. So since we need a schedule, we can just come here. So the schedulers here. You can create one from the example. This is easier. So let's create a schedule. All right, so we put the name. You can put a description if you prefer, and we don't really need. In reality, it's going to be a recurring schedule, but I think for this demo, let's leave it as recurring schedule. And set your time zone, and this is where you specify your cron job, right? So if you are familiar with how cron job works, so this is where you actually specify it and minutes. This is particular minutes of the day. So what's the time? Let me specify to run at, let's say, like 5 minutes from now. So let's say 20. Then the hours. What's the time? So this should be like 21. So let's put it at 20. Because I know. So the day of the month, you can leave it at question. So this, if you put question mark, it means that you are not specifying any day of the month. Then the particular month, you put star, meaning it's going to run at every month on this particular like time they're specifying. And day of the week, Saturday. This could be Sunday. This could be Monday. It could be any day of the week. And then the year is going to be star as well. So once you do that, it gives you this calculation and it's then telling you that okay, so it's going to run Saturday, 6th of June, 2026 at 2020. I think it's UTC. It's Let me check something. So I'm trying to get the time zone. Let's see. Okay. So it's +1. Okay. Yeah. So yeah, this is correct. And then, do we want a flexible time window? No, we don't need that. And you don't need to worry about that as well. So you can just go ahead and create it. And then this is where you put the trigger. Okay. So now we have our schedule. What are we scheduling to run? What do we want to run at this particular time? So for that, we want an ECS task. So we can select ECS here. and then we select the cluster. That is our weekly summary cluster. We select the task definition. That's what we defined there. And then we want only just one. So here you put the subnet, all the subnet IDs. So what they should have done is that they should allow you to be able to like just click and accept it. But they want you to manually specify the subnet. So I have to get the IDs of those subnets. This is not convenient. It's not convenient. Okay. So how do I copy all these IDs now? These guys are all right. So let's just take one for now, and I'll just put it here. The security groups. We don't need any security group for now, and we can just go ahead and create it, creating our schedule. So you don't have to worry about the like other data. This is just the main thing that we need for now. Okay, so it has been okay. It's been created. So I hope it creates within the time because this is like scheduled to run like 2 minutes from now. So I think our task is still going to be running. It's going to be run. Let me just stop this one. So let me stop. So what I can do is that um, so off screen, I'm going to go. I'm going to log into my other to this particular. I think this is the one working. This email address is the one working. So I'm going to log in here. So I'll show you the notifications I'm getting on this particular email address. So I'm going to do that behind the screen. Yeah. So in the meantime, can everyone ask questions because we are like 99% done. So you guys could ask questions now. Any questions? Oh yeah. Okay. Someone's asking for a notification. Okay. So yeah, you get. I'll show you the notification. So I'm trying to add the accounts that I subscribe to. But I think the notification is based on subscription basis. So the email account that subscribes to the notification is the email account that's going to get it. So I could use my number as well. But if I use my number, there's no way I'd show you. There's no way I'd be able to show you that. Okay. So I'm almost in. So I'm just having like a little technical, yeah. So was very slow to reflect. So the task should have run by now. Let me just check. Just for checking sake. Um, so yeah, so we had to stop it. So let me just run it again. Sorry. Okay. So I should get notification like any moment from now, like any minute. I should get them all the time. Okay. 23. Okay. So if I check the email, I should see notification. So this is notification here. So as you can see, it's so this is based on what I specified in the application anyway. So the total order 20, the revenue, the discounts, blah blah blah, the number of items that we sold, the failed orders, and the top product, the category, and the rating, and just a timestamp. So it's a good practice to always keep timestamp whenever you are like working with all these things. So the notification works. So whenever the particular time has been reached, the event bridge is going to trigger your container to run, and then once it's run, it sends. Once it runs successfully, it sends the messages. In this case, it's going to be like JSON data. It organizes it and it sends it to SNS. Then once it gets to SNS, based on the amount of entities that are subscribed to that topic, they all receive like emails like this. So in this case, it's email. So if I should subscribe my, like, let's say for example, I create another subscription, and I say SMS, and I put like, say for example, my number or your number. So if I should put your number here, okay, so they're telling us to use like a sandbox to do all this. It doesn't matter. But if I was to add like, say for example, your or my number here, when this thing is all like triggered, the notifications will go to my phone number as well. So you can trigger this for your phone number, your email. You can see like it actually goes a long way. There's data firehose, there's SQS. So SQS is a queuing system, another different service on it. So you can also send it to another Lambda function again that can do another thing. So let's say you have like you are sending this data to like a machine learning model to like perform predictions for a particular user or something like that. So you could send this to Lambda, and then once it gets to Lambda, Lambda can then maybe trigger like SageMaker, AWS SageMaker, so it can like maybe like perform an AI analysis on it, and like so this thing actually goes a long way. It's like Lego. You know how Legos are like what you can build with Legos. It's should I say is infinite. You can build anything with Legos. You can build a human being. You can build like cars and like with Legos. So that's how all this is as well. But this is just a simple illustration that I believe that I've done justice to. And to recap on the scenario again, so we are creating a notification system for an e-commerce application such that the parties involved can get notified on like a routine basis instead of them having to check. Like so instead of them having to log in to the website to check or log into the application to check, why can't you just get it on their phones or on their email or on their like Slack channel, for example, automatically without any extra work done? So this is like a simple architectural diagram that also overarches the solution on a very conceptual level. And this is the end product as well. The application runs successfully, and then we can get every single thing that we specified. So, are there any other questions? Because I believe this is the end of the demo, or rather like the solution. So any other thing that we do from here is just be extra. So this is why I set out to build. And okay, someone's asking for the repo URL. So I could just drop it in. Though I'm going to share all this together with the um yeah. So yeah, that's repo. You can just check out the code. The code is really simple. It's just a simple fast API application. So are there like any other questions? I see new people joining. That's nice. And if you are like building this by yourself, you should obviously like delete everything you created. So all the resources I've created, I'm actually going to delete them so that I don't incur like additional costs. Like I don't need, because like this is on my own account, so I have to delete them. So if there are no questions, further questions can be asked on the group, and you can reach out to me privately. Many people have been doing that, so like feel free. My DMs are very open. And also, if you are joining, because I know some, if you are joining like for the first time, we have like a vibrant community where you can join, and like you get access to like sessions like this, and you get access to the community as well, where you can ask questions and also share what you've learned. So I recommend you check that out as well. We are the AWS Cloud Club at the University of Lagos, and thank you for joining. Really appreciate you. So, Mike, is the end.